Hello friends, and welcome to this new Kubernetes services part 2. My name is Alok Kumar, and today we are going to discuss on the Kubernetes services, and this is the part 2 of that video. So what we are going to discuss, we are going to discuss on the type of Kubernetes services we have, and we are going to do the lab section also. If you refer my previous video on the Kubernetes, which is the part 1 of the services, then you can see that we all did all the things manually. We created the services, and then we define the endpoint where we have the IP of the backend pod, and the front end is communicating with the services, and services have the endpoint assigned for the backend pod IP. Okay, so in this session we are going to do all the things in an automated way. We create the services. Okay, first we create the deployment, then the deployment have suppose 3 replicas, and then we will assign a service to that particular deployment, so it will play on the basis of labels. Okay, so if we scale the deployment up or down accordingly, the endpoint IP will get scale up or scale down, or it will, you can say that remove the IP or increase the IP for the endpoint. Okay, so in the lab sections we discussed all the part that we are going to cover in the as a theory. Okay, so we covering the what we discussed in this particular video. So what are the type of Kubernetes services? We are mainly 4 types. Okay, the cluster IP, node port, load balancer, and the external name. But the 3 of the first one, the cluster IP, node port, and load balancer is frequently used. So cluster IP, it expose a service which is only accessible within the cluster. So this is, you can say this is the default one. If you didn't define the service type, it will pick the cluster IP. So what we did in the first part of the services, we created the cluster IP, because if you refer that particular video, we are not defining the service type, so it will pick the as a cluster IP, and it is accessible within the cluster. You cannot access it from outside the cluster. For that you have to use the node port. Expose a service via a static port on each node's IP. So you have to do in this way, like some IP and then colon and then the port number to access the container. Okay, and the third one is the load balancer. It exposes the service via the cloud provider load balancer. So if you create in the AWS, it will create the load balancer at the provider level, same as for the different provider level, and you can do a load balancing types of things. So at the back end, it's creating the node port. Okay, but for you are just accessing the google.com. You are not defining the colon and the port number. Okay, so in this way the load balancer will work. External name, it map a service to a predefined external name field by returning a value for the CD codes. So external name service are the similar to the other Kubernetes service. However, instead of being accessing via a cluster IP address. So we are going to discuss on both all the 3, cluster IP, node port, and load balancer, which is very frequently used as the Kubernetes services. So what is the cluster IP? We already discussed that this is accessible within the cluster. Cluster IP is the default. If you didn't define the service type, then it will pick as a cluster IP as a service type, which is used to expose a service on the IP address internal to the cluster. It access only permitted from within the cluster. So you already seen this architecture. We have the front end prod and the service have the endpoint, which have the 3 IP, and these all IP are of the backend. Okay, node also have the IP, but you cannot use the node to access it, because you have to it is something accessible from within the cluster. So you have to call the front end have the services attached, and the services have informations and the endpoint defined for the each of the back end. So it will if anything get removed, if the all the pod is the part of the, you can say, the deployment, so it have all the informations. Services play on the basis of the labels. Okay, this also we are going to see in the lab section. Okay, so it will work on when we have the nodes get scaled down or scale up as per the requirement, and the huge traffic it's coming, then you can scale up, increase the replica accordingly. So this is the cluster IP. For the node port, you can see that something is coming from the outside. Okay, so this is the node 1 and this is the node 1 IP, and you have the port number. Okay, with the colon you can accessing the port number, and first it's interacting with this because this service is listening on this particular port. Okay, and then we have the internal port defined where the traffic to route. Okay, accordingly it will get all the informations for the front end. So when you access this port, it goes to the front end, and then the service is called accordingly to access the environment, the application, you can say. Okay, so this is the default port 30,000 to this particular. You can define your port accordingly. If you mention in the configuration file, then it will create the port that you define in the configuration file. But if you didn't define, you only define the service type to be node port, then it will pick any of the number between these two. Okay, so you have, in the case of node port, you have to mention the service type. Okay, so if you talk about the load balancer, internally load balancer also create the node port to work internally. Okay, that we can see in the next slide. So this is the load balancer. Okay, for cluster running on the public clouds, so you can see that we take an example of the AWS. Okay, so we have the load balancer. If you create a service type to be a load balancer, then it automatically create a load balancer at the provider level, means the AWS if you're talking about. So suppose you call the google.com without any port, then it will call the load balancer. Okay, and the load balancer internally working for the accordingly working as a node port. Okay, so it knows where to go. Okay, because if each of the addresses have some node port assigned. Okay, so this is the dynamically each time it's getting changed, and accordingly it calling the environment, and the applications which is hosted inside the container will call. Okay, so Kubernetes will automatically create a load balancer and provide the firewall rules if needed, and populate the service within the external IP address assigned by the cloud provider. So you can see this particular architecture. So in the Kubernetes master or Kubernetes cluster, you can say we have one cloud controller manager which create the load balancer in the cloud. Okay, so as per the environment in which you are working, for each of the cloud Kubernetes will create a load balancer accordingly. Okay, to get the informations of the container, access the applications from the container. So you don't have to provide the node number, something like in the node port. This is the beauty of the, and you can associate this with the route 53 as well with your domain. You can just use the route 52 to get the address of the load balancer. So when you click any abc.com, it will route to the load balancer, and load balancer work accordingly, accessing the IP of the node with the node port. Okay, to access the applications. Okay, so now jumping to the lab sessions for the demonstration of the Kubernetes services, what we discussed in the theoretical part. So we are going to look into all these things. We will create a deployment. Okay, and we will associate a services as well, and we'll scale up and scale down accordingly and see the endpoint of the services, either it is decreasing or not. And we will also do in this session, like we will create a separate pod which have the same label as the deployment, and that will get attached to that particular deployment because the label is same. Okay, and for all the service type we are going to discuss, the cluster IP will covered in the service part 1. Okay, but we will see the cluster IP again, and then the node port, and then the load balancer. Okay, so now jumping to the lab session for the demonstration. Okay, this is my EKS environment where we have two nodes of instance type T2 small, and the EKS client is T2 micro. Currently I am connected with the EKS client kubectl. get node. We have two worker node. Ls, we have some file here. Okay, so first we are going to use the deployment, okay, where we are using the two replicas and we are setting some selectors, match labels, okay, that we can utilize during the creation of the services. Let me cat the deployment. Okay, so if you can see here the API version, the kind is the deployment and name of the deployment is the deployment. Labels, we are using the app nginx, and the specification you can see, and the replica is of 2, and selector, this is very important, the match label, we are using the label as a app nginx, the same we are having here as well. Okay, and in the container you can see that the name is the nginx, and the image we are going to use nginx 1.14.2. so this all piece of code have we taken from the Kubernetes documentation itself. Okay, and let me show the service as well. Cat service.yaml file. So here you can see that we are using the selector. So this service will using the selector, this labels, it run for the deployment, because the deployment also have the label. So when we scale down the deployment or scale up, whatever the port we are increasing or decreasing in the deployment will be the part of the endpoint of the services all the time. So this we are demonstrating in my first video in a manual way, and this is the automated way. So let's me deploy the kubectl apply -f. Okay, apply -f and the deployment first. So it create the deployment. Okay, and after that I need to deploy the services. kubectl apply, the file name is services. Okay, so kubectl get deployment. So you will find that one deployment having the two replicas and both of them are available, so you can verify it as well. kubectl get po, which is the short code of the pod, and both of them are running. So look into the service now. kubectl get svc, the short code of the services. So you can find that one service gets created and this is the default one. Okay, and here you can see the cluster IP. Okay, so each time we are creating the cluster IP, because we are not specifying here, if you see in the services, service type is not specified, so by default it's take the cluster IP, and this is the cluster IP. Okay, so and the port is 80. So we created the deployment and the services. Okay, now it's let's describe the service. kubectl describe svc and the service. So you will find two endpoint, and both the endpoint is of the pod. So here you can match it 101 and 125, 101 and 125. So now we are going to scale the deployment. Okay, so kubectl scale deployment, name of the deployment is the deployment, and the replica that we are going to set is of 4. So it's a scaled up. So if you see the endpoint at this point, or you can describe the services again, so you will find that the 3 is mentioned here and one more. So we have 4 endpoint, because we currently have 4 pod. We scale from 2 to 4. kubectl get pod, so you will find it here, the 4th pod is running. Now if I scale down accordingly, you can find the 2 pod now available, and if you look into the services, you will find only 2 points. So you can understand this in an automated way. When the traffic is increasing, we are scaling up, and when traffic is going down, we scale down our endpoints means the pod, okay, where our applications is currently running. So if I run a new pod, suppose just name it as a demo pod having the same image, okay, then that will be also the part of that particular service. Let me show you. Currently we have two, okay. Let's create one more pod, kubectl, which is not the part of the deployment. Kubectl run demo pod, this is the name of the pod, image is equal to nginx, okay, and the label we are defining here is as the same label, okay, app is equal to. So this particular pod is created, kubectl get pod, you will find one demo pod which is currently running, which is not the part of the deployment. But if you see the services, kubectl get, or describe it as we see service, you will find now 3 endpoint, okay. So this is the first endpoint, after that second, and the third, this is the demo pod, okay. One of them is the demo pod IP. So you can understand that demo pod is the part of now service endpoint. Why? Because we use the same selector here, because at the time of creation of the services we mention the selector to be used as the match label having this particular label, okay. On that basis the service pick the node, okay. That's why it's changing the endpoint accordingly as per the selector, okay. So hope you understand this point, okay. So now let me remove the deployment, kubectl delete deployment, because I need to create the node port again, so I don't want to mix anything. ctl delete service as we see service, okay. So if you go to the kubectl get pod, you will have one pod which is not the part of the deployment, kubectl delete demo pod, okay. So I can just clean it up. Now we have to look into the node port, okay. So for the node port we have one file here, let me broadcast it, sorry, cat node. So what, this is the service, and this service name is NodePort, okay, and the selector is global pod, and the type is the node port. We are not defining the port here, on which port, so it will create it dynamically, okay. So what we are going to do, we are going to run a sample pod with some label, the same label, global pod. So this service will pick that particular pod, okay. So for this we will use the imperative command kubectl run NodePort pod to identify the pod, and the labels we are going to use is of type is equal to global, the same we have here, okay. So global pod, and what image we are going to use for this pod is of type nginx, okay. So it will create it. Now deploy this particular services, kubectl apply -f, what is the name of the services, node port, okay. So kubectl get svc, so you can see that the node port services get created, and you can identify this as a node port here, okay. And this is the dynamic port which is assigned to this particular services, okay. So kubectl describe SVC node port. Okay, so here you can see that the endpoint is defined because we currently have only one pod that we created with the same selector. So this service picked it up. Okay, so now we required the node external IP. Okay, kubectl get node output of void. So this is the node informations. Now kubectl get pod output of void. Okay, so this particular pod get deployed under the 28 node. Okay, the 28 one, this one, and this is the external IP. So first thing is that we will open a new tab here and paste it. Okay, after the colon we need to specify the port, node port. So how can we get it? This is the node port that we have to use. Okay, so if you paste it here and enter, then this will not work. Why this will not work? Because this port is not allowed. So we are using the port, the node 28. So we will go into this. Okay, we have to check. Okay, so this is the 28 and our pod is running on this node 28. We already verified it. So if you look into the node and the pod is running on 28, and we taken the 28 external IP with using the port, node port. Okay, so all things are set, but the main thing is that we have to look into the security groups. For this we go into the node security group that currently it's using, and we have to copy it 31317, copy, and then go to this particular pod, edit it, here add one custom TCP. Okay, this is fine, paste it here, and for all the CIDR block. Okay, and let's save it. So once it's saved, you can refresh it, and here you have the message of the welcome to Nginx. So you can see this is node port. Okay, so we use the external IP of the node outside the cluster and access it. So hope you got my point, that what I am just want to demonstrate you. Okay, so now this part is done. We demonstrated the cluster IP, we demonstrated the node port. Now it's time to look for the load balancer. Okay, so let me close it. Let me delete all the things. kubectl get deployment. We don't have any deployment for this. kubectl delete, and what pod is node port pod. Okay, so we deleted it, and we delete the services as well. kubectl delete svc, and what is the name of the service? It's node port. Okay, node port, that service will be deleted. Okay, so all things are clean up. Now what we are going to do, we are going to use the load balancer. Okay, for this we are going to create a deployment, but this time we are using the imperative way to make it faster. kubectl create deployment, sorry, created, not created, create deployment. Let's say then the name of the deployment we are giving web app, and the image is Nginx. The port we are assigning as 80, and the replica, let's say it's have the replica of 2. Okay, let's create the deployment created. Now the deployment I created with the imperative way. Okay, so we have the two replica. Now I'm exposing this service with the services. Okay, using this deployment, we will name it as the same. The service name will be the same, but this time the type will be the load balancer, and I am doing in an imperative way. kubectl, just to make it faster, expose, and you can feel it that what is going on, exposing the deployment. Okay, so it will pick all the labels internally. Okay, the name of the services is web app. Okay, and the port will be 80, and this is the main thing. The type we are assigning here is of load balancer. Okay, so it will create the load balancer. If you look into the load balancer, here you will find one load balancer will create it, so it's loading. Now one is created. So if you copy this load balancer, or you can go here and kubectl get svc. Okay, so you can find one services is running which is of type load balancer. From here also you can take the external IP, or from here as well. Both are same. Just let me click it here, and as this is Nginx, we don't require any port. This is the functionality, or you can say the beauty of the load balancer, because currently we are relying on only one port. So let me remove it. So you can see that we getting the welcome to Nginx using the load balancer. Okay, so we already added the one port which is restricting, because it's not running on the one particular port. It's running for all the port, the load balancer. That's why we have to remove it. Okay, which we created previously. So in this way we demonstrated the cluster IP also, the node port, and the load balancer. Hope you like my video. If you didn't subscribe my channel, please do subscribe it. It's always motivate me. And share this channel link with your friends. Okay, this always help me to bring new videos to you guys. Okay, and have a nice day. Thanks for watching this video.